doesn't look very stable. Okay. So any questions from homework, or you guys are all like, I'm on minimal brain support right now, Jeff? All right. Just all deep breath in, let it out. All right, that's good. We're all alive. This is good. Because it's not helping our brain situation out. Exactly. So we did make it halfway through chapter 4. I do want to try to finish it up today. Did anybody not get that handout from the other day? We had anybody wasn't here last time? All right. You guys didn't get this, so to help you out a little bit. Who else? Everybody? All right. So if you just got this one side, it's a worked out problem. The other side is a problem we did in class. Okay. So are there any questions before I get back into new stuff?
What section are we
I don't know. I think I'll do an example problem from what we did, and then we're going to get into section 4.3. All right, so let's start there. Let's do it. So what we did the other day was, if they give me the data like this, let's see, so if I had 3, 4, 5, 7, sure. I like it, right? And again, this would come from, if I ask people, how many times a week do you work out, or something, right? And some people said 3 times, some people said 4 times, some people said 5 times, some people said 7 times. Right? It just happens to be this way in my sample, and you're like, I don't work out. And I didn't talk to you, obviously, right? my imaginary sample. We didn't have an imaginary conversation. So let's say that if I put 0.15 there, what does that mean? 15% of the people I talked to said they work out 3 times a week. All right, good. I like it. All right, so that explains this whole entry. I like it. As I fill these in, when do I have to start being careful?
When you get to 7.
I'm getting close, Joe. So what is that? 40, 40? Okay, so this will be, what's this got to be?
Something that equals
20. Good. Because the other ones are 80. Because this has to add up to be 1. So the sum of the probabilities has to be 1, and the probabilities have to be between 0 and 1. All right. So that's easy. We know that. But when I ask you why is this a valid probability distribution, you have to check these 2 things out. And be careful. I'm sneaky. I might make this 0.199. So this is actually going to add up to be 0.999, which is close enough to 1. But if you just say sum of 1, I'm like, you didn't even check. What the hell? So actually check. Right? All right, how we do this one? So the first thing we learned, I'm not going to redo the whole idea behind this, but since this is given to me in a different format, there's got to be a quicker way to find the mean, right? Instead of writing 15 3s and 40 4s and oh God, no. What I do is I use this format to come up with a different way, and we did. What do I put it? What's this column going to be?
X probability of X.
Yeah, X times P of X. Take each value and multiply it by the weight. So then what do you get here? That's right. And real quick, where should the mean be before you even add that together? Where should the mean be close to? Around 4, in between 4 and 5, so it's going to be about where it's supposed to be normally, right? It's not symmetrically done, but this is heaviest weighted, and this is going to pull it up a little bit, so it should be about in between 4 and 5. Right? Plus 7 is a higher number than what would be here if it was perfectly symmetric. But let's see what happens. 3, 4, 4.2, 4.7. Is that what it is? Jeff, get that. So in symbols, what did I just do? What is this in symbols? Sum of x p of x, which is also known as the mean. That's the formula for the mean. Now, before I get too far, let's see. If these were the numbers in a hat, and I was going to pick a number out, and I said, take a guess as to the number I'm going to take out, and the closer your guess is to the actual number, the more money I'm going to give you. You guys with me so far? You guys get a feel for this going on? And you don't have to pick 3, 4, 5, or 7. You could pick 3.2 if you want to be crazy, right? So what's your best guess? 4.7 is your best guess. Because it's the average of all the values. It's the thing that's closest to all the values. Taking into consideration all the values. Are you guys kind of with me? So what we call this, now this is kind of funny. I love this formula because another name for the mean is expected value. And what's the first part of this, the first 3 kind of letters of this look like? EXP, expected value. That's insane. So when they say what's the expected value, that's what you would expect to happen. That's going to be the mean. I would expect something around the mean to happen. That's what I would expect. So that's why we call it expected value. Good. I just want to say that now before I forget, because the book does say expected value. That's what it means. How do I find the standard deviation? What's the formula for the variance? Good. Makes sense to they're both squared, so they're both kind of like on even footing. The most common mistake is people forget to square the poor little mean dude. Right? So what does this tell me I need? I've got a column that gave me sum of x p of x, but now I need a column that's going to give me x squared p of x. So how do I create that from what I have? Yeah, if I multiply these together, I'll end up with x squared p of x. Now you also could just square this and multiply it by this. Math doesn't give a shit. Both ways are the same. You're going to end up with the same numbers. But the way I kind of taught you was do L1 times L3, right? If you're thinking about it in terms of your stat lists. So what's 3 times 0.45?
1.35.
Good. 4 times 1.6?
6.4.
Oh boy. 5 and 1.25?
6.25.
I like it. And then 7 and 1.4?
9.8.
8.4. 9.8. Yeah. So then when I add those up, if I add those up, it'll be the sum. I really want you guys, some of you guys still don't quite get this. So I have a column that are those. So when I add them up, I get that. Right? Because that says the sum of these. So the number I get when I add these up is actually this whole damn thing. This whole thing is a variable. Right? So what is the value of the variable for me right now? 23.4? 23.8? Yeah, looks like it should be something with an 8 at the end. 23.8?
Yeah.
And then how do I figure out the variance? Yeah, take this, plug it in. Shoop. Minus the square of the mean. Hopefully it's obvious if this comes out to be a negative number. Something went wrong, because you're about to take a square root and we can't have a complex standard deviation. 1.71? What about something? So that's before you took a square root, right?
Yeah.
And now take a square root.
1.3076.
So 1.308?
Yeah.
So let me just consolidate it. Mean was 4.7. Standard deviation was 1.308. So what percent of the data is within one standard deviation of the mean? Stay with me now. What goes in the middle? 4.7. Oops. Gotta hire somebody. And then you go down one of these and up one. You don't just add and subtract one unless the standard deviation was 1. You add and subtract one of these. Up one standard deviation, down one standard deviation. So the up would be 6.008, right? And the down would be 3.392. Yes, is that right?
Yep.
Good. I do trust myself, but you never know. It's been a rough day already. My brain is like, oh God. So, what numbers are in between there that's in my data?
4.
Yeah, 4 is in there. 5 is in there. And that's it. So would I say half the data is in there? If you do, that's bad. You'll lose points. Because what percentage of the data is 4? 40%. What percentage of the data is 5? So what percentage of the data is in there? 65%. I like it. So before I just had a pure list of numbers. I had to count and then divide by the total. Now I've got numbers, but the percentages of those numbers. I just have to add the percentages together. The percents are already there. I don't have to make them. Okay, all right. So that was a remarkably fast example of what we did last time. Let's get into new stuff. Let's get the new stuff. Oh, by the way, the book, I always forget this. If you're looking at examples of standard deviations in the book, they use the worst formula, x minus mu squared. They don't use the x squared p of x formula. If you want to, you can do that too. It's fine.
I have econ stats and that one, it's online, and I did that like all last week, and that was so much easier. It's so annoying.
I'm sorry, buddy. You're doing econ stats and this at the same time? Oh, okay. All right. Keep me updated. I'm always curious about how they teach my stuff.
It sucks the other way. It sucks. I wish
All right.
you were caught up. I wish I was like a week ahead or a week behind, I guess, in that class.
Sorry, we'll see. All right, maybe we'll catch up. Okay, so here comes some new stuff. So I don't know if you've picked up on this, but like on the test, I had to be very specific when I said the probability you pick a Republican and then a Democrat or something, right? Because if I said what's the probability you pick a Republican and a Democrat, it could be RD or DR. So you have to calculate both and add them together. So what we're about to step into is, let me give you an example. It's going to sound familiar, but then you're going to quickly, hopefully, see why we need a new way to calculate these probabilities. Or a more organized way to do it. So let's go back to left-handers, right? I'm still going to use 11%. So the probability of a left-handed American is 11%. Because I'm pretty sure 11% was all about Americans. I can't remember where I got that number from. All right, so far so good. You haven't done anything yet, haven't you? So let's say we pick 5 Americans. A murder. And I want to know what's the probability that exactly one of them is left-handed. Hopefully you understand why the answer to that question is not 11%. Do you guys see why somebody might think that? You might be somebody who thinks that. I don't know. Do you guys see why somebody might think that? You're like, well, probably left-handed is 11%. One left-hander is 11%. But why is that wrong? Because it's not taking into consideration the other people. So let's build this. This is kind of cool because we're going to build a formula based on things we already know, which is always nice. Give me one way this could happen. I got 5 people. I want one of them to be left-handed. So what could happen?
Left.
Let's call it left and not left. How's that? Is that cool? All right, maybe. You see why? Because then you might be ambidextrous, right? Ambidextrous? No? I give my left arm to be ambidextrous. What's that?
I play sports with my left hand and play with my right with my right.
Okay. There you go. I'm jealous. My poor little left hand, dude. You know? I can't, like, go when I play basketball. It'd be awesome if I could do this, but everybody's like, just guard him on this side. Oh, shit. You got me. Let's do this. This is getting kind of cumbersome already. So let me go ahead and say, let's call the probability of left-handed, let's call that P. Little p. And the probability of not left-handed, let's call that Q. So how would I write that then? I want the first one to be left-handed, which would be P. And what are the other 4? Q, 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 Q. What else? What's another way to have one left-handed? The left-hander could be the first one, or the left-handed could be the second one. Okay, does everybody see what's happening here? These are 5 people, and this means the first one's left-handed, or maybe the second one could be left-handed. So what is this really? Let me make sure you guys are with me on the math. This is a situation where I want the first one to be left-handed, and the second one to not be, and the third one to not be, or I want the first one to not be left-handed, and the second one to be left-handed, and the third one to be not left-handed. Or, so I keep adding as I go down. Or means add, and means multiply, basically, right? These are all independent. You being left-handed, if you stand next to somebody, they don't become left-handed or something. It's independent, right? It's like, whoa. Sorry, as you move away, I'm right-handed again. I don't know, it's weird. Or, I'll stop. That, or, thank God it didn't have like 11 people. Or, that, right? That's everybody, right? That's all the possible ways to match what this is asking for. So before today, I would have had to ask, what's the probability of the first one's left-handed and the other 4 aren't? Just like it did on this quiz. Because that's all we really had talked about how to handle. So now we're starting to get into other stuff. Now, how long is this list? 1, 2, 3, 4, 5 ways. Which makes sense. There's 5 people. There's 5 ways to have one of them be left-handed. Does that make sense? It's this guy, or so forth, right? So can you imagine, what if I had said probability exactly 3 left-handed? The first 3 could have been P, or the last 3 could be P, or the first 2 could be P and the last one, or the middle one could be P and the first 2 and the last one. That list is going to be stupid long. You with me? So thank God I'm not going to make you create the lists. We're going to talk about a mathematical way to count how big, or let's say it like this, have the calculator count how long this list is going to be. All right? So we'll get there. Somebody help me out. What's a better way to write each one of these mathematically? There are 5 of them, right? So if I consolidate, this is 5. And what do they all look like? What's Q times Q times Q times Q? Q to the 4th. So they all look like that, don't they? So I can. They're all like terms. Oh shit! I told you there's going to be a little algebra in here, and this is it. And you're not actually going to have to do it yourself on these problems. You just have to do it while I'm developing the formula. So whoever got really upset there about algebra being present, don't worry. Okay. So how do I calculate this probability then? What is little p dude? What is he? What's the value of him? 11%, because the little p dude was the probability of a left-hander. In fact, in general, I'm going to call p the probability of success. And q is the probability of non-success. I like that. That word ain't my vocabulary, Jeff. I just say non-success. Yeah. I like that. I like it. All right, let me stop there for a second. Is everybody semi with me so far? We're developing a formula right now that you don't even realize that's what we're doing. We're developing a formula. You're not always going to have to do this because, again, this list could get really long really fast. In fact, I don't know if you know this, but if you had like 11 toppings on a pizza options, there are upwards of 7 million possible combinations of toppings. That freaks people out, which appropriately it should. So the minute I get a few more people and I let a few more be left-handed, this list could get stupid big in the thousands, tens of thousands, hundreds of thousands, really pretty quick. This one's only 5 because I'm only taking 1 out of 5. I mean, so this list is manageable, right? So this is the number that we need help with. Why does these two make sense? What do I want to have happen? What do I want to have happen? I want 1 to be left-handed. So how many P's do I have? 1. So that must mean the other 4 are Q's. I really want you to get this. So if ignoring this number for a second, the list would get longer. But if I said I want 2 left-handers, what would this have been? And this would have been? That's crazy. Holy shit. Let that part be easy. This is the part we need help with. How long would the list be if there were 2? I don't know. It actually wouldn't get too long yet. But it's long enough. And even a bit more than this is like, good Lord, man. It was painful just watching you write this, Jeff. I understand. So to calculate this would be 5 times 0.11 to the first times. Where am I getting that from? Yeah. So if P is 0.11, Q must be the rest. P plus Q is always 1. Because they're opposites of each other. 8, 9 to the 4th power. So now just put in that calculator, see what you get. Let's see what we get. Anybody got that for me?
Three, 4, 5.
0.345?
Yes.
That's neat. Is that right?
Good job.
Sure. I planned that out. Is that what you guys are getting? Everybody? Yeah. Okay, cool. So if I had 5 random people, the probability that one of them is left-handed is 34.5%, which kind of makes sense. Because to have 4 of them be right-handed, I should expect that to be pretty possible because not very many are left-handed. A lot of people are right-handed. How's that? Or, not right-handed, just not left-handed. Should be. Sorry. All right. So what does this mean? I have a formula now. If I want, so let's identify some variables. N means the same thing it's always meant. So N is the total number. So in this case, what would N have been? 5. There's a total of 5 people. I like it. X is the number of successes. Why was left-handed a success? Because it's what I'm looking for, right? So success in this case doesn't have to be nice. It could be a dead person. It could be a rabid squirrel. It just depends on what I'm looking for, right? What's the probability that out of 40 squirrels, 2 of them are rabid? All right, a success would be a rabid squirrel. You with me? It's not like, hey, I got a rabid squirrel. No, it's just because mathematically it's what I'm looking for. I like it. Cool.
But it's not the 11%, right? It's just the 1.
No, yeah, exactly. This is the number of successes. P and Q are the probabilities of success and failure. I like it. So this is the pure number of successes. So far, ignoring this number for a second, to make a general, you got a lot of shit here, let's use this. A general formula. If I have n things, and I want to know what's the probability that I get x successes, and P and Q are the probabilities for individuals to be a success and a failure, right? And it's going to be some number, we have to figure out what this is, times P to the x, because x is how many successes I want, so I want x of these bad boys. Now here's where it gets a little bit weird. n minus x. I love it. Because if x are successes, the rest are failures. So we still have to figure out what to put here. This number, whatever this is, it's got to represent what?
All of your options.
How long the list would be. How many options there are to meet that question. All right, what we got? How we doing?
Good. So-
Yes? Okay, that's right. I'm trying to gauge. It looks like 8 of you are on the edge of asking something, and so that's why I'm stopping. You're on. Okay, all right. And if you think about it, this is a beautiful equation. If I want 7 successes, there's going to be a 7 on the thing that means success. Holy shit. And then we got 12 total people, 5 failures. So these two always have to add up to be,
5.
well, not this, don't point at that, just always have to add up to be the number. In this case, that's 5, but that won't always. So let's fill in the last thing we have to fill in to make a complete formula. We don't have this number. I want the number, and this is the one of the 2 times this measure, that I'm going to be fine with you just going in the calculator and plugging it in. So calculators are built to count, right? So I wanted to count how many total things there would be. Let me get this ready. I got to show you where it is. So if you gave me back that calculator, if you want to borrow it again, you can come up and grab it. Oh, yeah, that's right. What? I can't trust you guys anymore. I'm gonna have to wait to see what time it is. What is it? 11:51. All right, thank you.
So there's a way to do it on the calculator? Like what we're about to do, like it's 5 exclamation point is what you're about to do, right?
We're not even going to go to the exclamation point round. I'm sorry, buddy. That's all right. I'm going to show you a shortcut. Real quick, I think the book shows you something with exclamation marks. I always forget this. I don't think they even, no, I think the book actually just says use the calculator to do the whole damn thing. So I will show you how to do that. Hopefully you know me by now. I don't want you plugging numbers in just to get the whole answer. I'm going to allow us to get this part from the calculator. The rest of it I better freaking see set up, right? And then after that, I don't care. As long as you set it up correctly, I don't know what happens after that. Right? But you got to be able to set it up correctly. So I'm going to show you how to get this through the calculator. And then I'm going to show you, and then we'll do this problem again, and then I'll show you how to get the ultimate shortcut so you can check your work. So what this is it's kind of cool. I could say I've got 5 people, and I want to choose one of them to be left-handed. Does that make sense? Is that a reasonable way of saying that? So the way in math we write that is 5 things, choose one of them. That's, math people, we like to consolidate stuff. We're all about shorthand. We don't like to write a lot, especially me because I can't. So in your calculator, I'll show you where this counting thing is. Okay. Oh, that's good. Oh shit, did somebody? I love when people mess with shit and don't.
Doesn't have to be on the computer.
Let's see if somebody locked that in.
There you go.
There. I like it. You just have to push the button twice and then hey. That's the computer reminding me that it's in control. Okay. So now watch. Here we go. If you want to play along. So let's recreate this 5. It's kind of silly. We can see the answer is supposed to be 5. We can actually make the list and count it. So we're like, let's just make sure the calculator is able to do it too. So the way I do this is hit the number 5. 5. And this is on that calculator handout that's online, if you want to print it out. But then you hit math. And look at all the shit that's in math. It's neat. But I'm going to go over to probability. And then number 3 has got the choose thing in there. See that big C in the middle? They use the letter R instead of the letter X, but oh well. So they have R for successes, and we have X for successes. Do you see how the NCR matches up with 5 as N, choose, 1 success? Okay, good. Right? No? You guys cool with this shorthand? Alright, I'm just showing you how that NCR is a representation of the shorthand. So that's how you know that's the button to go to. Don't go to National Public Radio. Go to number 3, 5, choose 1. Yay, 5. So let's try something else. You ready? What if it would have been? Oh yeah. Well, let's see. So if you had 11 toppings, so remember how to do this. The thing with this one is you could have extra cheese and extra pepperoni and all that kind of stuff. But just if I had 11 toppings and I could choose 5 of them, that's already 462. But you know what I'm saying? It's way bigger than you thought it would be, isn't it? Already. But then you start to add in, well, you can add, like, you can have extra pepperoni or extra cheese or triple cheese or something. Then you get into the millions. So if I had 11 people, and I wanted 5 of them to be left-handed, my list would be 462